So question 2 is asking us to describe what happens to the graph of a function when you replace x with 1/3 x, y with -2y, and y with y plus 1. So what I think is a good way to go about this is to first draw a function that's easy for you to manipulate and just kind of try these things out and see what happens. So I'm going to draw a function. I'm going to choose the function y equals x, which is nice and easy and goes on this diagonal here. So this line is y equals x. So I'm going to pick a nice and easy point on this graph of 1, 1. And just kind of see what happens to this point when I replace each of these things that are in the question. So when I am multiplying or adding something to the x, I'm going to be doing a horizontal manipulation. And when I'm multiplying or adding something to the y, it's going to be a vertical manipulation. So in each case, I'm going to keep the opposite value the same and see what happens to either my x or y value. So for example, let's start with our equation of our line, which is y equals x. And so I'm going to start with replacing x with 1/3 x. So I get y equals 1/3 x. And so I want to see what happens to my x value, so I'll keep my y value the same. So y is going to be equal to 1. And I'm going to solve for x. So to do this, I'm going to multiply both sides by 3. And I get 3 equals x. So my new point is out at x equals 3, y equals 1, which is here. And so you can see that in this case, we've done a horizontal expansion by a factor of 3. So if we go back to our question, that is answer I. So that's the answer to the first part. Let's try the next one. So in this case, we're still going to start with our equation of our function y equals x. And I'm going to replace y with -2y. So in this case, I want to see what happens to my y value. So what happens vertically. So I'm going to keep x the same. So my x is going to equal 1. I have -2y on this side, and I'm going to solve for y. So that gives me y equals -1/2. So now my new point is x equals 1, y equals -1/2, which is down here. So in this case, we can see what's happened is we've done a reflection in the x-axis, which if we look at our question is it's 6. But what we've also done is we've done a compression, and we've done a vertical compression by a factor of 1/2. So that's 4 as well. Okay, so let's move to our last, the last part of the question, which is replacing y with y plus 1. So we're going to start again with y equals x. I'm going to replace y with y plus 1. And again, in this case, I want to see what happens vertically, so I'll keep x the same. So y plus 1 equals 1. That gives me y equals 0. So in this case, my point is here at x equals 1, y equals 0. And I can see that in this case, what's happened is I've got a translation 1 unit down. So that is answer 8. translation of 1 unit down. So the answer to this question is 1, 4, 6, and 8 when we do these manipulations to x and y. And if we look at this, we can see the pattern is that whatever you are replacing x with, x or y with, you kind of have to, what happens is the opposite of the manipulation you're doing, if that makes sense. So when we replaced x with 1/3 x, we actually expanded by 3. But when we multiplied y by 2, we compressed by a factor of 1/2. So that's going to be helpful moving on when we have more complicated functions that we are translating or expanding or compressing.